All right, welcome back. We're going to be taking a look here in this video at example 1 from section 2.1 and how to find the area between two curves. In the last video we talked about how we could extend the concept we learned from calculus 1 to find the area between two curves, and we found in theorem 2.1 that we could find the area between two curves by taking an upper function, the integral of an upper function minus a lower function. That's when we have a graph that looks like figure 2.2 here, where we have an upper curve and a lower curve. And then when we have a right curve and a left curve, like case 2, it's going to be similar, but this time we're going to integrate with respect to y. And it's going to be the right curve, or the right function, minus the left function. So in order to determine whether or not we have this case 1 or case 2, we really need to probably look at a graph. And so I'm going to come back here to example 1 and let's go ahead and graph these two curves. I'm going to pull them up real quick on Desmos. I hope you have a graphing device with you. If not, you can always use Desmos as well. And so we put these curves in here. We have y equals x plus 4. That's the first curve. And then the next one was y equals x squared minus 2x. I'll go ahead and reposition this. It looks like we have one point of intersection here at around -1, 3. And we have another intersection point, it looks like at 4, 8. And then for the quadratic, x squared minus 2x, it looks like there is a vertex at 1, -1. So those are kind of the points of interest there. And so we want to find the area between these two curves. In your notes and when you do the homework, you should always sketch the graph. It's a good habit to get in the habit of doing this. And so I'm going to go ahead and do that on the other paper. But before we do that, let's just think about, is this that type 1 where we have a top function and a bottom function, or is it the type 2 case where we have a left function and a right function? And hopefully you all agree with me that this is definitely one where we have an upper function, which in this case would be the y equals x plus 4. And we have a lower function, which is that quadratic, y equals x squared minus 2x. So let's go ahead and go back and let's go ahead and sketch real quick what the graph of this looks like. So we have, put some axes on here real quick. Again, this is a rough sketch, so it's not going to be perfect, but this is good to have in your notes for reference. So -1, 3 was that first intersection point. -1, 3. And then our second intersection point was at 4, 8. And it looks like I'm going off the screen here, but it's going to be kind of up here somewhere. And then our vertex was at 1, -1, which is going to be right here. So this was 1, -1, then we had 4, 8, and of course that was a line. We had a line between those 2 points, and then there was a parabola that went down, went between those two curves. So it looks something like that. And so the area in question here is all this stuff right here. Right? This is the area that we care about. And so we could draw in that rectangle, that representative rectangle. I want to get in the habit of doing this. Notice it goes this way, so that little thickness there, we're going to think of that as our dx. And then our our top, or our top function is going to be the y equals x plus 4, so our top function. And then our bottom function is y equals x squared minus 2x. And so another question you might be thinking is, how do we find the point of intersection? What if we didn't have the graph? Could we find where these two curves intersect? And that's a good skill you need to know. And the way you can find the point of intersection, or points in this case, points of intersection, is by setting the two curves equal to each other. So we can take x squared minus 2x and we can set it equal to x plus 4. And hopefully you know how to solve something like this. But because we have a quadratic equation, we basically need to get everything on one side and set it equal to 0 so we can factor. So in this case, we want to move over the x and move over the 4. And so we'd end up with x squared minus 3x minus 4 equal to 0, which does factor. Factors to x minus 4 and x plus 1, which of course gives us those two answers that we can see in the graph. We had -1 and 4. Remember, in the graph, it intersected when x was equal, these two graphs intersected when x was equal to -1, and also when it was equal to 4. And so in order to find the area for this problem, the area is going to be the integral. We're going in the x direction. This is a dx, so we're going to go from -1 to 4. And then remember, we're going to take the top function, which in this case is x plus 4, minus the bottom function, which in this case is x squared minus 2x. And all right, integrating here, let's go ahead and clean this up. So we have the integral from -1 to 4. And if we go ahead and distribute that negative sign here in between, we end up with -x squared. That's a positive 2x plus that other x, so positive 3x plus 4 dx. And now we can integrate. So we end up with -1/3 x cubed plus 3/2 x squared plus 4x, evaluated from -1 to 4. And when you plug in those limits, when you plug in 4, you end up with -64/3 plus 24 plus 16 minus, and you plug in -1, you end up with positive 1/3 plus 3/2 and then minus 4. And when you go ahead and combine all that together, you end up with an answer of 125/6. And this is an area. We don't really have units on it, so if you wanted to add units, you could just make it generic. You could say units squared. But our answer there is 125/6. So hope you liked this video and everything made sense. If you have any questions, make sure you let me know. Thank you.